Close your eyes and imagine you're a merchant in ancient Babylon 5,000 years ago. You have a warehouse full of grain, dozens of customers, complex trades involving silver, barley, and livestock. You need to track inventory, calculate profits, convert between different measurement systems, and do it all without making a single mistake, because one error could bankrupt you. You have no calculator, no smartphone, no pencil and paper, not even the number 0. How do you do mathematics? That would challenge even a modern accountant. The answer changed human civilization, the abacus. And today, we're uncovering how this simple collection of beads became humanity's first computer, how it trained the human brain to think in revolutionary new ways, and why understanding the abacus reveals the very essence of mathematical thinking. Welcome to Math's Whisperer, where we explore the hidden stories behind mathematics. I'm your host, and this is Season 2, Episode 1. The abacus doesn't look impressive. Beads on rods. That's it. No batteries, no screens, no algorithms running in silicon. Yet this deceptively simple device represents one of humanity's most profound inventions, the externalization of mathematical thought. Let's travel back to ancient Mesopotamia. Around 3000 BCE, the Sumerians were building the first cities, creating the first writing system, and facing a problem that had never existed before: complexity at scale. When you're a shepherd with 10 sheep, you can count on your fingers. When you're managing a city-state with thousands of workers, massive construction projects, complex taxation systems, and international trade, your fingers aren't enough. You need a tool that extends your mind's capacity to calculate. The earliest known calculating device was a clay tablet with columns drawn on it. Merchants would place pebbles. The Latin word calculus means pebble in different columns to represent different values. Move a pebble from the ones column to the tens column, and you've just performed addition using physical objects to represent abstract numbers. This was revolutionary. For the first time, numbers weren't just sounds you spoke or symbols you wrote. There were things you could touch, move, and manipulate. Mathematics became tangible. But the true genius of the abacus emerged around 2700 BCE, when someone we'll never know who had a brilliant insight. Instead of loose pebbles that could be lost or accidentally moved, what if you strung beads on wires or rods? What if you created a permanent frame where each rod represented a different place value? The Mesopotamian abacus was born. Here's how it worked, and why it's so clever. Imagine a frame with several vertical rods. Each rod represents a place value. Ones, tens, hundreds, thousands. On each rod, you have beads that can slide up and down to represent the number 243. You'd have 3 beads in the ones position, 4 beads in the tens position, 2 beads in the hundreds position. Simple, right? But here's where it gets interesting. To add 243 plus 185. You don't need to memorize addition tables or use an algorithm. You physically manipulate beads. Add 5 beads to the ones rod, but wait, you only have 10 beads total on that rod. So you take 10 beads from ones, push them back, and move 1 bead up on the tens rod. This physical action is carrying in addition. The abacus teaches you place value in carrying, not as abstract concepts but as physical operations. Your hands learn what your brain needs to understand. The design spread and evolved. The Chinese developed their own version, the swan pen, around 200 BCE during the Han Dynasty. The Chinese abacus became incredibly sophisticated with a different design. 2 beads on top, each worth 5 units, and 5 beads on bottom, each worth 1 unit for each rod. This design was genius for the Chinese number system and allowed even faster calculations. A skilled Chinese abacus operator could perform calculations faster than someone using a mechanical calculator. Even in the mid-20th century, the Japanese refined the Chinese design into the soroban around 1600 CE, reducing it to 1 bead on top and 4 on bottom, making it even more efficient. But here's what most people miss. The abacus isn't just a calculating tool. It's a thinking tool. Remember our Babylonian merchant from the beginning? Here's what the abacus gave him that transformed not just commerce, but human cognition itself. It gave him the ability to hold complex numbers in external memory while performing operations. It was humanity's first RAM, our first ran-back memory. Modern neuroscience has discovered something fascinating about abacus experts. When skilled abacus users perform calculations, they're not just manipulating beads, they're manipulating mental images of beads. Studies using brain imaging show that expert abacus users, even when performing mental calculations without a physical abacus, activate the visual and spatial processing regions of their brain. They've internalized the abacus. They're visualizing beads moving in their mind. This is different from how most people do arithmetic. Most of us use language-based processing. We're essentially talking through the calculation in our minds. But abacus experts are seeing the calculation. There are documented cases of blind abacus users who can perform calculations faster than sighted people using modern calculators. How? They've built such a powerful mental model of the abacus that they don't need to see it. They manipulate a virtual abacus in their mind's eye. This reveals something profound about mathematical thinking. Mathematics isn't just about numbers as abstract symbols. It's about building mental models, representations, and frameworks that let us manipulate abstract concepts as if they were physical objects. The abacus teaches us that mathematical thinking is embodied. It happens not just in the abstract reasoning centers of our brain, but in the visual spatial systems, the motor control systems, the parts of our brain that evolved to manipulate objects in the physical world. Let's talk about what an abacus can actually do, because it's far more powerful than most people realize. Addition and subtraction are obvious. But multiplication, division, square roots, all possible on an abacus, and in the hands of an expert, all remarkably fast. Here's how multiplication works, using a simplified example. To multiply 7 times 8, you're essentially adding 7 to itself 8 times, but you use clever techniques to do it efficiently. You break larger multiplications into smaller components. Use the distributive property without even thinking about it, and let the physical manipulation guide your thought. Division is multiplication in reverse. Square roots use an iterative approximation method that's essentially the ancient version of an algorithm. In the 1940s, there was a famous competition in Tokyo between a Japanese abacus expert and the best electric calculator of the time, operated by a trained American soldier. The abacus won in 4 out of 5 categories. Only in large multiplications did the calculator gain an advantage. Think about that. 5,000 years of cumulative human refinement of a simple tool produced something that could compete with electronic technology. The abacus spread everywhere. Civilization needed commerce. The Romans had their version, called the Roman hand abacus, small enough to carry in a pocket. Medieval Europeans used counting boards with the same principle. The Russians developed the shati. Every major civilization developed some form of bead-based calculation. Why? Because the abacus solves a fundamental human limitation. Our working memory is tiny. Most people can only hold about 7 items in working memory at once. Try to do a complex calculation, say 347 times 283 purely in your head, and you'll quickly lose track of partial results. The abacus externalizes memory. Each bead configuration represents a number you don't have to remember. You can focus your limited working memory on the next step of the calculation while the abacus remembers your current state. This is the same principle behind all later calculating devices. Mechanical calculators, computers, smartphones. They're all descendants of the abacus. All based on the insight that you can represent numbers physically and manipulate those representations to perform calculations. You might think the abacus is obsolete in our age of smartphones and computers. You'd be wrong. In many Asian countries, abacus training is still part of elementary education. Why? Because research shows it develops several crucial cognitive skills. First, concentration. Operating an abacus requires focused attention. You have to coordinate visual perception, motor control, and mathematical reasoning simultaneously. Second, mental calculation. Students who learn abacus can eventually perform calculations mentally by visualizing the abacus, giving them a powerful mental arithmetic ability. Third, spatial reasoning. The abacus trains the visual spatial parts of the brain, which transfer to other domains like geometry, physics, and engineering. Fourth, number sense. When you manipulate beads representing place values, you develop deep intuition about how numbers relate to each other, how they compose and decompose. Studies have shown that children who receive abacus training show improvements not just in mathematics but in general cognitive abilities, including memory, attention, and problem solving. The abacus teaches us something profound about the nature of mathematical thinking. Mathematics often seems abstract, disconnected from physical reality. We talk about numbers as if they're pure concepts floating in some platonic realm. But the abacus reminds us that mathematical thinking is grounded in physical intuition. Before you can understand the abstract number 7, you understood 7 objects. Before you could add symbolically, you could combine groups of objects. Before you could multiply, you could make groups of groups. The abacus leverages these physical intuitions. It takes the abstract operation of addition and makes it concrete, moving beads. It takes place value a sophisticated abstract concept and makes it spatial. Different rods for different values. This is the secret to developing mathematical thinking. Ground abstract concepts in concrete representations. Build mental models you can manipulate. Make the invisible visible, the abstract tangible. When you truly understand a mathematical concept, you can represent it in multiple ways. Symbolically, visually, physically, verbally. The abacus is one such representation for arithmetic. So here's my challenge for you. Whether you're a student struggling with math, a professional using mathematics in your work, or just someone curious about developing your mind, consider getting an abacus. Not to replace your calculator, but to understand, viscerally and physically, what calculation really is. Spend a week learning basic operations. Feel the beads under your fingers. Watch numbers emerge from configurations of objects. Experience the moment when abstract arithmetic becomes concrete manipulation. You'll understand numbers differently. You'll see calculation differently. And you'll have touched the same tool that ancient merchants used to build the first cities, that medieval scholars used to advance mathematics, that continues to train millions of minds worldwide. The abacus is more than a calculator. It's a window into how humans learned to think mathematically. It's a bridge between concrete and abstract, between physical and mental, between ancient wisdom and modern cognition. And that's the story of humanity's first calculator, a device. So simple a child can use it, so profound it still teaches us about the nature of thought itself. If this story changed how you think about mathematics, subscribe to Math's Whisperer. We're releasing daily episodes all season, exploring mathematical thinking, ancient wisdom, and modern mysteries. Tomorrow, we're traveling to ancient Babylon to discover why we have 60 minutes in an hour and 60 seconds in a minute. The answer will surprise you. Hit that subscribe button, ring the notification bell, and drop a comment. Have you ever used an abacus? Or would you like to try? Let's explore mathematics together, one whisper at a time.